Huh? Huh? I'm on my desktop. I got the camera. This is how it is. We're not even gonna be using this. I just wanted to. I bought a 25. I bought a 25-foot HDMI cable just to set this damn thing up. It wasn't expensive, but you know. I actually am at the point where I really would just like to lock in. Um, Give me a second here. All right. I'm gonna get some ice. I'm gonna get some LaCroix. I gotta wake up. We got 3 hours to do this homework. I think it won't be so bad. Um, but this is homework 11. We need homework 12. All right. It's hot in here, man. I haven't gotten to go for a run, anything like that. I probably not gonna be using the whiteboard. Maybe I'll use the whiteboard. I'll be right back. Yeah. Okay. All right, so we just need to do um uh so what is it that we're doing? We're doing let uh is this what we did? This seems like so stupid, but I don't really care. All right, so now we should be able to do this. All right. Now you have a linked table of contents, each on its own page. All right, so now we can pull up the book. Okay, that one's easy. 11. Sketch the solution curve in the phase plane. The x of t and y of t graphs. Okay, that one's pretty easy. What's the next one? 15. All right, 15. Okay, that one's also easy. Maybe we'll do this like by hand or something. 21. 15, 21. How often does the mass cross the rest position? How often does it cross the rest position? It should approach it exponentially often because it's gonna oscillate around it forever. Okay. And 27. Show that it's a saddle. So showing that it's a saddle is just showing that one of the eigenvalues is positive and one's negative. But it has to be a fixed point, so you have to make sure that 0, 0 is a fixed point. But 0, 0 is always a fixed point of any linear homogeneous differential equation, so we're good there. Um. Okay, find the eigenvalues, sketch the phase plane. On the phase line, sketch the. All right, let's just get started. These aren't that fun. All right, so problem 5 is this is gonna be all right. So, 7. Um, all right. We just need to add this to our make types. Okay. Oh, hey, for some reason it's working. Yeah, it must just be the let's see. A B. It must just be the testing that does it. That's what it is. It's just the testing. So that's actually great. But we're just plotting the phase plane. But it'll be easier to plot the phase plane if we do it the right way. So let's lock in. So what do we need open? We need. Oh my god, it's so stupid. Stop. Do not ever. I don't know how it. Whatever. Software can get worse. That's the crazy part. Software can get so much worse. It can just get. It can just keep getting worse. Yes, this is what I want. So I want A. I really just wanted A, I think. Okay. Wait, what am I trying to do? Map types. Typst. Let's just do this. Wait, why didn't that work? Oh, maybe that's actually right. That could be right. Okay, so let's just say here. First off, we need to transcribe this system. Actually, you know what I want to do? So let's say y prime of t, and let's try to do this to types. This should give me, yeah, so that's nice. So that's that. But then we want a dot y. But then this dot is probably not going to. So we don't really get as much as I wanted. That's the problem, is you gotta keep adding more and more. Okay. But that's okay. So what is it? It's bool bool dv bool y t t can we zoom this in? Okay, is equal to, and then what we want to do this feature. What feature do they think I'm trying to get? I'm trying to add a new line above myself. Let a equal, and then what's my matrix? Let's just do this. A types K E. What the hell is going on here? K. Oh wait, we need to do bool y. All right. Okay. We find that the eigen values are, and then what we can do is we can do. See, but what I'd like to do is I'd actually like to This is not too hard to do. What we should do is we should generate the string. Here, I'll copy in the string. I should get lambda one. It should generate this. Lambda 1, lambda 2. And this should be to n, but we don't really need to do that quite yet. But then this is going to be an array of the numbers. It's not that hard. 4, 1, dollar. Okay, then we want, let v1 v2 equal to, and then let's just need to turn this into this dollar, this dollar, this. Okay, so I want to I want a function that will generate the types, a wolfram function that will generate the types for Typst eigensystem. Okay. Yes. And I guess I assume that everything is diagonalizable. I don't know if that's fair. All right, come on. Stop writing so much freaking And does it use the Typst function? No. Oh, wait. Let's just see if it works. I don't even actually care. Thank God. But is it 4 minus 1? Oh, it is. Oh, well, that's nice. Okay. So then I can just do this. Nice. That's so much better. Then we just want basically lambda 1 equals lambda 1. Okay. Actually, I want to know what happens if I do b solve y prime of t is equal to a dot y t. And I think I need to do this of t, right? D-solve? How does D-solve work? First off, this is definitely wrong. This needs to be like this. Oh, and I think I don't even need to... I think it just learn. I think it just knows. Oh, see, that's the problem. Hold on. Clear y. See, this is just gonna evaluate. Damn it. All right, let's just call it x. Doesn't really matter. Should I do this? Oh, but you know what? I think... No, I think what you need to do is you need to do x of t is equal to x of t, y of t. And then I can do... Oh, God. So this thing is so annoying. I don't know why they do that. It's like, you... Like, Steven, come on, man. The problem is... Wait, why doesn't... This should be listable, right? This should give me a list. So then why didn't it do it? Okay, let's just oh, it's got an embedded linear solve in there, man. But that's actually kind of nice. But what we want is just we just want this. So the function of t. Okay, I don't know what I'm doing. Let's okay, so then so the general solution is it's going to be bool y t is equal to lambda. Oh no, this is going to be k1 k. Oh my gosh, what's happening? K1 e to the lambda 1 t v1 plus okay. All right, so now we can I need this and this. So this is just -1. So that's fine though. Okay, so we expect our phase porch. So wait, if I were to just plot this, ooh, I got this. Nice. All right. So we have for our system we have lambda 1 is equal to 4 and v1 is equal to 1. Lambda 2 is equal to -1. V1 is equal to -1, 1. So now if we have this, we're going to have, 1, 2, 3, 4, 1. I have this point. So if I just, okay. And then I have -1, 1. Okay. Now, this one is negative, so it's going to come in like this. This one is positive, so it's going to go out like this. So what we're going to have is all right, so there we go. That's what that looks like. So that's pretty easy. Now that we've done it, phase port ret. Okay. I always forget the names of the phase portrait is. See, I hate this graph because it's like this graph is not the phase portrait, right? Why is this the lowest res picture ever? Why did none of these plots have axes? Don't they know that you need axes for axis labels? Okay. Oh, see, why is it? Um, I think we need to like refresh it. I forget how I fixed this the last time, but it's like bugged for some reason. Why isn't it? Why can't I send anything now? Ay. 'Ugh, I love that it just doesn't show the fucking plot. There we go. Okay, I don't know why it didn't. All right, good. That looks good. So this is problem 5. All right, nice. Problem 11. That's the wrong problem. 3.13. So this one. All right. Okay, so how do we want to approach this problem? We're going to do the same thing as before, but I want to figure out the absolute fastest way to do this because sometimes I just bumble around. Okay, so the first step is you find the general solution. So that's the first step. Find general solution. Since it's a 2x2, what we can do is we can actually just write it in here, actually. So these are going to be lambs, vex, and then this is going to be equal to... Actually, is this the case that it's going to be sum? How do I do this? Right, because I want to write some, but I want it to be unraveled. See, you don't want this. You want... Maybe there's a way to do like a list comprehension or something. Let's look up if there's a Typst list comprehension. I don't even think that's what I want though. I want like... or whatever. For right now, let's just do this. I think you have to do lambs.at 0. So it's gonna be a generic K1 oh wait, we need to put this in math. And that's gonna be an e to the... Oh wait, this is up here. T plus K2. Oh, and this needs to have a vex.at 0. And then we should be able to just turn this into this. And this is going to be a 1, and this is going to be a 1, and this is going to be a 2. So then if I do that, so let's actually general solution lambda 1, lambda 2, and that should be symbolic, and then we can do v1, v1, v2, right? Do I need to call it somehow? Do I need a hash? Why doesn't this work? Expected integer found content? Why does it need to be an... I don't even understand why that's the case. What? Arrays have to be of... You can't... No, what? That's not true. You can have an array of anything. Maybe a... Oh, you know what? I'm literally writing homework. It's like not that complicated, bro. I'm literally just trying to write my homework down. Okay, but this seemed to work, right? Was this the same as what I had? Yeah, but what we need is this is the right hand side, general solution on right hand side. Okay, but it's not even as okay, we'll get faster. All right, so but we need our system. So let A equal, and then we need So first off, 4 minus 2, 1, 1. Okay. Now we just need to do ES is equal to eigensystem of A. Okay, and now we can do, what is this function that I wrote? Typst eigensystem? Typst eigensystem of E's. Oh wait, that's not what I wanted. Yeah, I want this to be of A. And this gives me this. Okay. Well, first off, we do need, actually, we need type of A. Copy this over. Okay. Guys, we can just say, we can just call this lambs vex, and then we can, ugh, God, that's so annoying. So we can say, so first off, let's write the system. So where are we right now? We're right down here. Okay, so we're gonna get okay. This is our system. Now we get the eigensystem, and this is gonna be the system to find the general solution, and that's gonna be y t is equal to gen solution lambs vex. But I think I have to hash this. Okay, and so now, and I'm just plotting these, right? Wait, did they say 13? Oh, they said 13, not 14. I need to freaking oh, that's nice of you. I think I did the wrong one. Hold on. This is for exercise 13. So we need to redo all this. 13. Minus 4, 1, 2, 3. Wait, minus 4, 1, 2, minus 3. 1, 2, minus 3. All right. So we need to, yeah. So this is like kind of our flow in this thing. So I can't believe I did that, but that's okay. Not a big deal, really. We just need to then rerun this, and then rerun this, and then we copy this. And actually, you know what we can do? We can change lambda names. We can just do yeah, so instead of this, we're just gonna get lambs, and then, and I think we can get rid of this and this, and then we can get rid of this and this is just gonna be vex, and then we can get rid of this. Okay, so let's try that again. So now we can get Typst eigensystem of A, let lambs vex. All right, good. Now we're starting to get somewhere with this thing. So we needed to fix this. Okay, great. Okay, and what do we need to do? Now what is the actual problem? Sketch the, oh Jesus, I hate these sketch ones. These sketch ones starting 9:30, man. These sketch ones are so boring. Okay. Return to the... Oh yeah, we need to write this. We refer to the initial value problems from the exercises. Sketch the solution curves in the phase plane. And the x of t and y of t graphs for the corresponding. Okay. Okay, we need to also write down 1 0. Okay, let me just write that down. A is 1 0, B is 2 1, and C is -1 -2. All right. So why are we doing this? Maybe just for the practice. So we have the general solution. Now we can... We don't even need to do this. Okay. All right, so let's just Oh wait, we forgot to put the ICs in. Why does this have... How did I do this earlier? Hmm. This is gonna be so wait, we could just do this. Ooh, a single figure? That's smart. That's so nice. Dude, this thing is so good at making plots. It's awesome. Let's just see if the eigenvectors line up. Minus 1, 1. Wait, is that the right problem? No, that's 11, right? Yeah, that looks right. And then 1, 2. Yeah, that looks right. 1, 2. Yeah. Okay, cool. Problem 15. 23, 3.2. This is the y double prime plus 4y prime plus y equals 0. Alright, that's the easy one. But didn't this one... Oh, it never asked us to plot it. What did we get for the eigensystem? The eigenvectors are like just above that line, and then pretty far below that line. Because this is gonna be like minus 3.5 or something like that. Yeah, that's gonna be like minus 3.5, 1. That's gonna be like this, and then this one is gonna be 2 or minus 2. So that's gonna be like this, and this one's gonna be like that. Okay. Okay. I love that it just does this, man. Are we finally done with these trash problems? We can get something good. Okay, the harmonic oscillator is m times the acceleration, so my double prime plus by prime plus ky is equal to 0. Okay, so the harmonic oscillator is one 176. We need the yeah, 1 okay. Okay. I think we should just be able to do this. This should be easy enough. But I just copy and paste this into here. I go like this. Okay. Write the second order equation in the corresponding system. Okay. Okay, then compute the characteristic polynomial. Okay, so then we get we need to clean this up, but wait, let's just do this. But this is gonna be our okay. So then you get 7 lambda plus lambda squared plus 6. Lambda squared plus 7 lambda plus 6. Okay. Let's just do this. So then this becomes wait, hold on. Find the eigenvalues. Okay. It's -7. No, it's -6. -6 and -1. Is that what I wrote? Good. Okay, so to find the all right, so first let's we gotta fix this. This is always really annoying. A, B, C, D. Does this have a yeah, that's what I thought. But this does have a line in it. So yeah, you don't want that. Okay. You kind of want a space here, but you don't want a okay, first let's find the general solution. So we can just do type eigensystem of A. We get this code. So we get this, and then we get yt is equal to gen solution lambs vex. But I think I have to do, I don't know when I have to do the hash versus when I don't do the hash. I don't even know. But so we solve for 0 equal to vec 2 0 to find that. So now what we want to do is to do this, we have -1 -1 -1 -1 6 1 times k1 k2 is equal to 2 0. Okay, so then we can just use linear solve. All right, so we have so we need to take ES, we need to take transpose of ES2, okay? And this is our matrix. And then we want to do, linear solve of this with 2 0, because that's our initial condition. So then we get this. And we can just pipe that to Typst. Okay. And we get to find that we don't want to vec, actually. We want to undo this. We just want it to be k1 equals and k2 equals. Okay. So this is a specific solution. And let's just let's get a phase for this system. Can you do the same plot with direction, field, and straight lines, but only use the trajectory of y0 equals to 2 0. Okay. So in this case, um, where is this from? This is from the enum. Yeah. What number is this? What are we on? 21? This plot demonstrates that we only cross the y equal to 0 once. Or no, 0 times. 0 times. Discuss the motion of the mass for the initial condition. So basically, so its velocity is really high, then its velocity swings back over, and then it just dies. What? That doesn't make any sense. To see how many times the mass crosses the rest position, solve y of t is equal to 0. Where's the other plot? They're saying at t equal to this. If this plot's right, then that's not true. Oh, at minus. Okay, wait. Yeah, yeah, yeah. That's actually pretty interesting, though. At minus 0.35. Okay. All right. So and how fast? The geometry of this space is actually really interesting. What is the eigenvectors and eigen? So minus 1, 6. This is the fast one. So this green one is the fast one. So and if we look at this, its rate of change. Okay, and then our last problem, I'll be back in a second. Our last problem. Alright, I'm back. So what's the problem now? It's 23, right? No, is it 27? Oh, it's 27. Bro. Okay. See the thing is it's almost even better if I just do this. Actually, you know what I could do? I could have a global thing for the problems themselves. No, I don't know if I want that because I want to reset it each time, right? Or this, but then you go like this. Now, is there a way to like shift? There's no way to do that. Okay. Estimate the time t at which the solutions with initial conditions 1. Whoa, that's pretty cool, actually. Now that problem is pretty rad. We haven't gotten to actually do. Okay, show that 0 is a saddle. So first off, we need to let A, and we just do our general thing. -2, 1, 0, 2. Did I get that right? I'm so bad at remembering this. -2, 1, 0, 2. Oh my god. Okay. -2, 1, 0, 2. Jesus. That is so annoying. Alright. So then we have yp is equal to hash A yt. Alright. This stuff is so fun. Okay. Okay, so what we want to do is hate typing. Um Bro, what? Forgot to you have to hash this. Just do this. I would like to do this in a loop, but I'm too stupid right now. That's interesting, man. They're symmetric. Wow, that's super interesting. You can find the general solution for the both of them, and then you could take their difference. Oh, wow. The known formula for the matrix exponential of a 2 by 2 upper triangular? That's crazy, bro. Yo, this is so sick. Wait, this doesn't look right. What? that for real? Oh wait, I have this plot. It seems like they're not growing, they're not growing, they're not growing. And then they start growing. But maybe that's just... Oh, this is like the best question we've gotten in this section. This is so good. But I'm just gonna do this. Let's get the other plot. Wait, they're one apart or they're... Is there an approx? All right, that is everything. All right, I'm gonna download these and submit them. I think we're good. It takes so long, and it's actually, I think you actually learn less because you're trying to play this coding game of like, how do we do this as fast as possible instead of just like sit there and grind it out. But all right, that's it. Peace out.